job.
All right. Hi, everyone. My name is Emily Santos, and I'm a PhD student at Utah State University. I study functional ecology and wetland restoration, and today I'm going to talk to you about a restoration project we have going on the north shore of Utah Lake. Okay, so as many of you know through your own work and through the previous presentations, the way that water is moving through our landscapes has really changed dramatically. Out here in the West, we're used to variability, but in the recent decades, upstream infrastructure has affected what's coming downstream. And this is compounded by climate change, so we're seeing greater drought, more intense storms, and just more unpredictability overall. And this is really clear also at Utah Lake, where we have major swings in water level within and across years, and then also these patterns are really shaped by past water management and now amplified by extreme climate. So what does this look like on the landscape? So this is an within-year variation in water availability. So the top photo was taken this April, and the bottom was taken in September. And this kind of shows you the change in available water during the growing season from summer to spring to summer. And this is when we would typically do restoration work. I'm going to talk a little bit more about our seeding efforts, but I just wanted to do a little sneak peek. You can actually see in this bottom photo where we've seeded and where the water level was when we seeded, because we seeded right down to the water. So yeah, just a sneak peek, but I'll talk about that more later. So this water availability or variable water availability makes restoration hard. These native plants have evolved under predictable variable hydrology, but it's these really extreme swings that are making it difficult. And this is particularly challenging for the plugs and seeds that Addie talked about, so this is one of our ways of doing restoration. And that kind of passive restoration approach that also Addie mentioned, that's like waiting for the natives to come and recolonize themselves, that doesn't always work under these conditions. So what do we do? How do we adapt? And that's kind of the core behind the Utah Lake Wetland Restoration Demonstration Project. Here we're looking at passive recolonization on the North Shore, and we're comparing that to active seeding. And we're kind of breaking this down into three main goals. First, to assess seed bank viability. Second, to monitor natural recolonization, so that's that passive restoration. And third, to evaluate seeding strategies. All right, so the first question, what's in the seed bank and is it still viable? So what's in the seed bank or the seeds that are like already in the soil is often our first hope in passive restoration. If we have a robust seed bank of native seeds, then we might not need to do much more, but we don't really know yet. So we need to understand the richness and if these seeds in the seed bank can withstand the hydrologic variability that we expect, those extreme flooded conditions and extreme drought that we expect on the shoreline. So to answer this question, we conducted a seed bank assessment where we collected lots of soil from the shoreline and also from sediment from under the ground, under the water, where we knew the lake level would drop through the season. And we brought that back to our greenhouse and we germinated it. And we were able to characterize the viable seeds in the seed bank. We did this in April, and we've been growing them out for the last 6 months, and actually today is the very last day of the experiment, so I don't have a ton of results, but I can kind of let you know what we found in general. So there were a lot more species in the seed bank than we were expecting. It's super rich. There's a lot of native plants. There are some invasive plants, but there's no Phragmites, which is incredible. This is really promising. I love seeing how much potential is in the soil. And the next kind of step of this is that we also collected some seed bank samples that we're putting under a resilience treatment. So this is meant to really capture those swings in water levels that are within and across years. So we have 3 different treatments, 2 years of flooding, 2 years of drying, and then like alternating flooding and drying. And in 2 years, we'll repeat the greenhouse experiment. We'll grow out these samples, and that will show us how resilient the seed bank is and how these species might stand up to these variations in water level. So next question, what happens if we let nature take its course? So for this, we're monitoring the passively recolonizing vegetation. We've set up plots all over the north shore of Utah Lake, and we're using a quadrat method to measure species composition. We'll be repeating this for the next 3 years, so this is just, preliminary first year of data, but we're trying to understand how long it takes for natives to return, how does water availability shape which species establish and when, and then also compare what we're seeing in the field to what we're seeing in the seed bank. So does the potential within the seed bank actually represent the recolonization that's happening on the shoreline? And so this is just like a little bit of some of our results. So we did see overlap between our seed bank and what we're seeing in the field. And like I mentioned, there's Phragmites in the field, but not in the seed bank, as well as Tamarisk, which is one of the other invasives that Addie mentioned. And so this effort is really going to help us understand if passive recolonization is enough on the North Shore or if we need to step in and seed. So the next question is, what happens when we actively seed? So this happened this summer. We did a big seeding effort with Forestry, Fire, and State Lands. We have 3 different sites on the North Shore with 3 blocks of randomized and replicated experimental plots. Each of these squares is 1/10 acre that we hand seeded at the same rate as the broadcast seeder would seed a large-scale seeding effort with Forestry, Fire, and State Lands. And we'll be monitoring species cover in these plots, comparing our seeded areas to control non-seeded areas. And that we'll be doing that for the next 3 years as well. The question that we're trying to answer here is, does seeding lead to more diverse and stable communities? We seeded with 2 different seed mixes, a low and a high diversity seed mix. Our low diversity seed mix is mostly composed of workhorse species, so these are species commonly used in wetland restoration. And then our high diversity mix is those low diversity species combined with a bunch of other native wetland species that are well suited for the environmental conditions at Utah Lake, including a lot of charismatic pollinator plants. So we're really excited to have both of these mixes and seeing how they compare to one another. So some preliminary data from our most recent vegetation survey, we found really nice results that showed high diversity seed mixes increased native cover and decreased the bare ground when compared to no seeding, our control plots. And this is really getting at something that Addie also mentioned. So if we're decreasing the amount of bare ground, we're decreasing the chances that Phragmites, which are still we're controlling them, but they're still in the area and they're very prolific with their seeding. So the less bare ground we have, the better chance we have for other natives to recover. Let's see, oops. Oh yeah, so this is a clear signal that adding species diversity pays off in the first year. Again, this is just the first year. We'll be doing more years of monitoring to see if these trends change, if they remain stable. We're also tracking costs and logistics through this project. So this is an example of what it costs to do the seeding. This includes the cost of the marsh masters that we used and their tractors and the broadcast seeder, which is the largest cost. It doesn't include all of the effort that happened in our lab with testing for viability and also when we devised our seed mixes, we did an equal proportion of viable seed per species. And so there was a lot of work to do those calculations as well. This is going to help us understand what level of seeding gives the best return for effort in the long term. So yeah. This is kind of our timeline for the project. We're on year 2 of 4, so we have a long ways to go, but we are excited about some of the overall deliveries for this project, which are going to include seeding guidance for extreme hydrology, a cost-benefit trade-off that compares ecological benefits versus the cost and effort of the seeding, practitioner training materials, and a detailed seed bank resilience report comparing that baseline to our resilience treatments. Okay, just wrapping up, this project is really about developing practical tools for a messy and increasingly unpredictable world. And Utah Lake is just one case study, but these lessons can be applied across the Intermountain West or anywhere that wetland restoration practitioners are coming up against variable hydrology when they're trying to plant. So with that, I'd just like to thank and acknowledge all of our collaborators. Lots of graduate and undergraduate students from USU have worked on this. Also our seed collectors at Great Basin and Sterner Seed. Keith, who will be presenting after me, and folks who have helped with the seeding effort. So thank you.